This is our sixth and final lesson on radicals, and we're solving radical equations. Before we get into solving radical equations, let's just solve some normal equations that we're used to seeing. So this first guy, I'm going to have to subtract 13x from both sides. So I'm going to end up with 4x equals 32. Divide both sides by 4. I get x equals 8. And let's make sure that's a solution by putting it into the original. And it is. Part B, the first thing we can do is see that 2 over 4 is the same as 1 over 2. And now we can multiply both sides by 2 to get rid of that 2 on the bottom. So I'm going to multiply this side by 2 over 1. Oops. 2 over 1. And I'm going to multiply this side by 2 over 1, or just 2. So 2 over 2 is the same as 1 over 1. So I end up with x minus 5 equals 12. Add 5 to both sides. I get x equals 17. Check it in the original. Brackets first. And 24 over 4 does equal 6. Okay, our next guy, we've got an inequality. For the most part, we deal with these the same as equalities. So first thing I'm going to do is get x by itself by subtracting 7 from both sides. So I get x is less than negative 2. Obviously, this one has infinite solutions, so let's just pick one solution. Say negative 6 is less than negative 2. So if I put in negative 6, I get 1 is less than 5 is true. Alright, this guy, I want to get the y's on the same side. I'll subtract 5y from both sides. I get negative 2y is less than or equal to negative 9. Divide both sides by negative 2. And I get y is less than or equal to positive 9 over 2. Okay, an easy number less than 9 over 2 would be 0, so let's try it with 0. 3 times 0 is less than or equal to 5 times 0 minus 9. So I get 0 is less than or equal to negative 9, which isn't true. So what's going on? Okay, well, let's have a look over here on the far right. Let's say I've got 6 is greater than 4. And let's say I divide both sides of that by negative 2. So I ended up with negative 3 on that side, and I ended up with negative 2 on that side. Well, negative 2 is greater than negative 3. So anytime we multiply or divide both sides of an inequality by a negative, our sign is going to switch. So over here, that's going to have to be y is greater than or equal to 9 over 2. So let's try, say, 10 then. 10 would be greater than 9 over 2. 9 over 2 is 4.5. So let's try y equals 10. So I get 3 times 10 is less than or equal to 5 times 10 minus 9. Notice this inequality in the original doesn't change, right? We always do our verification checks in the original completely unchanged. So I get 30 is less than or equal to 50 minus 9, so 30 is less than or equal to 41. That is true, verifying that y is greater than or equal to 9 over 2. Okay, here's our first example with an actual radical equation. First thing we always have to do is state restrictions. So in this case, x is going to have to be greater than or equal to 0. Now, same as usual, just divide both sides by 3. So I get root x equals 5 over 3. To get rid of the square root, I'm going to have to square both sides. So x is going to equal 25 over 9. Okay, so let's First, check that that satisfies our restrictions, and it does, so we're okay there. So let's see whether or not it makes the original true now. So 3 times the square root of 25 over 9 equals 5. So that's going to be 3 times root of 5 is, or 25 is 5, root of 9 is 3, equals 5. 3 over 3 is the same as 1 over 1, so that guy works. Okay, so restrictions this time are a little bit different. We're going to have x plus 1 has to be greater than or equal to 0. So to find out what's going on with x, we'll subtract 1 from both sides, and we get x is greater than or equal to negative 1. So here's our restrictions. X is greater than or equal to negative 1. And now I can start solving this. So let's add 5 to both sides. So I get 4 root x plus 1 equals 8. Divide both sides by 4. 4 over 4 is 1. 8 over 4 is 2 over 1. So I get root x plus 1 equals 2. Now I can square both sides. I get x plus 1 equals 4. Minus 1 minus 1. X equals 3. Okay. Is 3 greater than negative 1? Yep, we're okay there. So now let's verify it in the original. Do the inside the root first because it's like brackets, so the square root of 4. Square root of 4 is 2. So I get 8 minus 5 equals 3 is true. Example 2, again we need to state our restrictions. This time they're easy. X just has to be greater than or equal to 0. And now I want to get all the root x's on one side, so I'm going to subtract 2 root x from both sides. And I can put the numbers on the other side in the same step, so I'm going to add 4 to both sides. And I got 4 minus 4 is 0, and I got negative 2x and positive 2, or sorry, 2 root x and positive 2 root x is 0. So I've got 1 root x on this side equals 5. Ugh, that's messy. Square both sides, I get x equals 25. And let's check that in the original. Oh, first, let's make sure that it's greater than 0, which it is, so we're okay there. And now let's check it in the original. Always put them in brackets when you sub them in. So 3 times 5 is 15. 2 times 5 is 10. So I've got, oops, that's supposed to be a plus. So I get 11 equals 11. All right, our next example, restrictions are going to be a little more complicated, so let's do them over here on the far right. So I get x minus 1 has to be greater than or equal to 0. Add 1 to both sides there. X is greater than or equal to 1. And I also need 2x plus 3 is greater than or equal to 0. Subtract 3. 2x is greater than or equal to negative 3. Divide by 2. X is greater than or equal to negative 3 over 2. Notice I divided by a positive, so the inequality doesn't switch. Okay, let's do a quick number line here, just to think about these for a second. So there's 0, there's 1, there's negative 3 over 2. So one of the restrictions says we have to be greater than or equal to negative 3 over 2. The other restriction says we have to be greater than or equal to 1. Notice that both of these have to be true. Like, for example, if I had x equals 0 here, then that wouldn't be greater than or equal to 1, so this guy would be no good. So really we're looking at this area over here where both of them are true. So what we really need is x to be greater than or equal to 1. Okay, that was pretty much the hardest part of this. Now we just need to square both sides because both sides have square roots. So I get x minus 1 equals 2x plus 3. Subtract x from both sides, and I'm going to subtract 3 from both sides. X minus x is 0, and 3 minus 3 is 0. So I'm left with negative 4 equals x. Okay, let's fire it into our original here. Oops, that's 2 times negative 4 plus 3. So I got the square root of negative 5. And we can stop right there, because as far as this course is concerned, there's no such thing as the square root of negative 5. So that's no good, so we end up with no solution. Putting x equals negative 4 into this equation will not make it true. Okay, so we've got our formula here. D equals root 13h, where d is the distance in kilometers to the horizon, and h is the height in meters above sea level. Okay, and we need to build a platform so that we can see 50 kilometers away. And we'll talk about this 100 meters in a second. For now, we need to figure out how far above sea level we need to be so that the distance to the horizon is 50 kilometers. So we'll plug in 50 for d equals the square root of 13h. Square both sides. Ugh. We get 2500 equals 13h. Divide both sides by 13. 13 over 13 is the same as 1 over 1. So we end up with 192.3 meters for h. Okay, now they say the base of the tower is at 100 meters. So there's our 100 meters for the base of the tower. So the tower is going to have to be here above 100 meters. So basically, to find out how tall our tower has to be, 100 meters is taken up by, 100 meters is taken up by land, basically, above sea level. So we can take off that 100 meters taken up by land. So our tower has to be 93.2 meters high. Okay, the most important thing on these radical equations is just make sure you get the radical by itself first, and then square both sides. That's basically it. Oh, and also make sure you verify your solutions, because sometimes they won't actually make the original true, so they won't be solutions.